Good morning, this is Dr. Turner for Fundamental Math. Today we are looking at 9.5, the last in the Unit 9 series, and we are looking at two rules today. We are looking first at the negative exponent rule, and then we are looking at the zero exponent rule. So both of these are derived from looking at our quotient rule, which if you recall, the quotient rule was when we took two exponential expressions and we were dividing, and the rule was keep the base, subtract the exponents. That's covered in 9.3. 9.5, we have a couple cases that we get. First is the negative exponent rule. And that's perhaps the easier one of the two. So negative exponents are essentially a shortcut for exponents in the denominator. And the rule is written as a to the negative m is equal to 1 over a to the m. So it is a way of writing exponential powers that we have in the denominator, where we don't have that exponential power in the numerator. For instance, let's say I had an expression like x squared divided by x to the fifth power. Okay. If I'm just simply using my quotient rule, 2 minus 5 would give me x to the negative third power, because we just do 2 minus 5. However, negative exponents are not considered simplified. Now, based on my negative exponent rule, that tells me that this should be 1 over x cubed. We can get this by doing expanded form. So for instance, if I have x squared, x times x, and then x to the fifth power, which would be 5x's, if I look at this in expanded form, I have two pairs of x's that cancel. And that doesn't leave me with nothing in the numerator. That leaves me with a 1. Remember, you can always multiply anything by 1 without changing the value. So simplified, this is 1 over x times x times x, or 1 over x cubed. Okay. So you want to always simplify your negative exponents. Don't leave them as negative exponents. So again, when you are looking at just let's say exponential question sheet, you might have cases where you're combining more than one rule that we've talked about. For this assignment, mostly it's going to be just looking at, let's say, x to the negative fifth power. Well, how do you simplify that? Oh, that's just 1 over x to the fifth power. Number 3, if I have 4 to the negative fifth power, oh, that's 1 over 4 to the fifth power, right? So you just flip it and change the sign to be positive, okay? If you have a negative exponent in the denominator, just as an example, let's say it's 1 over x to the negative third. Now, there are a couple ways you can get this, but if I simplify using my negative exponent rule, that means I have 1 over x cubed in the denominator, which creates a complex fraction. If I want to simplify a fraction, right, I can put a 1 underneath that numerator, and then I have keep, change, flip. And once I get done simplifying all that, I end up with x cubed. Now that's the more complex way to do it, involving complex fractions. How I remember it is that if I have a negative exponent in the numerator, then I'm going to move it to the denominator and make it positive. If I have a negative exponent in the denominator, then I'm going to move it to the numerator and make it positive. That's meant to be a shortcut, take it or leave it, but that's your negative exponent rule. And then the other rule for 9.5 is your zero power rule. And what this rule states is that basically anything to the zero power is 1. Now this throws students off a lot because we're just used to thinking of, multiplying something by 0 as being 0. But a to the 0 or anything to the 0 does not equal 0, it equals 1. Doesn't matter what the expression is, whether it's x to the 0, whether it's 10 to the 0, whether it's something super complex. No matter what it is, anything to the 0 power is 1. Now, how we get this would be same thing using the quotient rule. Let's say I had x cubed divided by x cubed. Based on my quotient rule, 3 minus 3, that gives me x to the 0. Now, there's a couple ways you can look at this. One is just by your basic rules of division. Anything divided by itself is 1. Therefore, by definition, this would have to equal 1. You could also get this by doing expanded form, x times itself 3 times over x times itself 3 times. And you could cancel out 3 pairs of x's, but that doesn't leave you with nothing because you can always multiply by 1 without changing the value. That's it for 9.5. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.